So after reading this problem, we find out that they're asking what is the speed of the runner A at 2 seconds. We're going to start there. The reason why is this 5.2 seconds is not going to come into play for the beginning problem, the beginning question. The acceleration for part A, 16A, is going to be 1.9 meters per second squared. And here we're just going to use t equals 2.0. So he's still going to be accelerating after this point, but we're only concerned with getting to this point from rest. Since he's at rest to start off the run, its initial velocity is 0, and the question asks you for the speed. We're going to assume forward. It's still going to be a vector velocity final. This is what we're searching for. So we take our equations and we determine which one we're going to use. So we need a VF. We have a VF there. We don't have a VF there. We do have a VF there. We do have a VF there. And then the variable we don't have here is distance or displacement. We're not even concerned with it. So any place we have a D, we can't use it. We already crossed that one out. We can now cross this one out. We can now cross this one out. The only one left over is going to be the VF equals VI plus AT. So I'll write that equation over here. VF equals VI plus AT. I have my equation. And it's already rearranged for you, so all you have to do is just solve. VF, let's plug the VI, the 0 is going to go right here because that's the initial velocity. He's going to accelerate, so he's going to get faster by 1.9 seconds, meters per second, every second. That's what acceleration means, meters per second per second. So every second he's getting 1.9 meters per second faster, and in this problem starting from rest, and he's going to go for 2 seconds. So you can already kind of assume what's going to happen here. If you go on 1.9 meters per second faster every second, it happens for 2 seconds. You're pretty much multiplying these two together. Start at rest, so that's going to be your final answer, your overall final. And so we take our calculator. 1.9 times 2, and we get an answer of 3.8. So 3.8, and the unit for velocity is going to be meters per second. So at that point in time, the answer to A is going to be that he's going 3.8 meters per second after the 2 seconds. So that's the first part. Now when you take a look at the second part, we kind of do the same thing, but we're going to create a new givens list. So here's part B. And here we are still accelerating at 1.9 meters per second. This is going to last for a total of 5 seconds. He's still going to start with initial velocity of 0. We could start at the end of this problem, and then it would be just a few more seconds left, but it just makes sense to do. Actually, this is going to be 5.2. So this time is 5.2 seconds. And we're concerned with his final velocity at the end of the race. Well, we don't know when the race ends, but we do know something. At 5.2 seconds, he's no longer going to be speeding up or accelerating at this rate of 1.9 meters per second. So really, we want to find out how fast he's going at 5.2 seconds. Once we know that, how fast he's going at 5.2 seconds, we know that he's going to keep on going that the rest of the race until the very end. So AT, VI, VF, AT, VI, VF, same equation. We would have picked it the exact same way. VF equals VI plus AT. VF is question mark, that's what we're looking for. So VF equals, starting from rest, this time we're going to be accelerating at 1.9 meters per second every second. That should be squared over there. 1.9 meters per second squared. And we're going to do this for 5.2 seconds and find what our end result is going to be. So we get our calculator, and we have clear 1.9 times 5.2, and his max velocity is going to be 9.88 meters per second. So 9.88 meters per second. That's our answer. He's going to run that after at 5.2. He's going to be seconds. He's going to be at this velocity forward. And he's going to keep that continuously because it says that the runner's acceleration is 0 for the rest of the race after that point. And so you're just trying to find a final velocity at the end of the race, so this is it.